The sequence of events surrounding NASA, the October 1st government shutdown, and the close approach of the interstellar object 3I/Atlas has raised numerous questions about transparency, scientific communication, and the timing of data releases. When more than 15,000 NASA employees were furloughed on October 1st, the agency lost an enormous portion of its workforce at precisely the moment when one of the most unusual astronomical objects in recent history was approaching a critical observation window. This closest approach to Mars on October 3rd had been anticipated for months because it offered the best opportunity for space-based instruments to gather high-resolution imagery and vital data that could help scientists understand both the nature and the origins of 3I/Atlas. Many astronomers were already frustrated by the shutdown, noting that years of preparation and planning for coordinated observations were suddenly at risk. Yet when NASA surprisingly released preliminary information to select mainstream outlets on October 4th, just one day after the flyby, questions multiplied rather than diminished. The agency had previously stated that processing the data would take several days, possibly longer, due to the complexity and sheer volume of imagery collected. Instead, NASA quickly asserted that the object was just another ordinary comet, offering no technical documentation, no spectral data, and not even a single supporting image from the October 3rd observation window. This abrupt shift, combined with the lack of scientific transparency, led some researchers and independent analysts to voice concerns that essential information was either being withheld, minimized, or rapidly framed in a way that downplayed the object's unusual behavior. These concerns are not rooted in conspiracy theories, but in the scientific record. For months leading up to the Mars flyby, astronomers around the world had been compiling detailed observational data on 3I/Atlas. Among the most prominent voices in the field was Harvard astrophysicist Dr. Avi Loeb, who has spent years studying interstellar objects and anomalies associated with them. Loeb, known for his willingness to challenge conventional interpretations when data warrants it, emphasized repeatedly that 3I/Atlas displayed characteristics that did not align with a typical comet, asteroid, or debris fragment. According to Loeb, the object required far more attention and continuous monitoring than NASA's early public statement suggested. Loeb and his team gathered approximately 4,000 observations from 227 observatories across the globe, creating one of the most comprehensive datasets available for an interstellar visitor. Their analysis revealed a peculiar and significant anomaly that could not be easily dismissed. The object was losing roughly 150 kilograms of mass every second, an enormous outflow directed toward the Sun, as confirmed by high-resolution Hubble images taken on July 21st. For any natural body, the act of shedding mass in a preferred direction creates thrust in the opposite direction. This is basic physics, comparable to how a rocket expels exhaust gases to produce motion. In previous interstellar objects like Oumuamua, non-gravitational acceleration had been a major factor of debate. Yet in the case of 3I/Atlas, something even stranger occurred. Despite the significant mass loss, the object showed no measurable deviation from a trajectory governed solely by gravity. In other words, the outgassing did not push or alter its path in any way detectable by even the most sensitive measurements. This lack of deviation could only be explained if the object had an extraordinarily high mass relative to the amount of material it was shedding. Loeb calculated that for the evaporation not to produce a detectable thrust, 3I/Atlas would need to exceed 33 billion tons. To put this into perspective, such a mass, if composed of solid material, would imply a diameter greater than 5 kilometers, making it roughly the width of Manhattan. And importantly, this figure represents only the lower limit, meaning the actual size could be significantly larger. No one could confidently assert that the object was simple, ordinary, or well understood with such extraordinary physical requirements. The mass estimate alone challenges the notion that 3I/Atlas can be casually dismissed as just another comet among millions. The timing of the government shutdown only heightens suspicion. When NASA abruptly lost much of its workforce, the agency's communication capabilities, scientific review procedures, and public outreach mechanisms were dramatically weakened. it became far more difficult for independent scientists, journalists, and watchdog groups to verify claims, request data, or monitor internal developments. Opportunities for rigorous cross-examination of any early conclusions were diminished. Meanwhile, NASA's selective release of preliminary information to certain mainstream outlets on October 4th, while withholding raw images, graphs, or reports, adds a layer of discomfort for those who believe scientific transparency should be at the forefront, especially when dealing with an interstellar visitor. Critics argue that such selective disclosures to favored media sources risk creating narratives before the broader scientific community has a chance to examine the evidence. Dr. Loeb's observations highlight a deeper issue within space science: the growing number of interstellar objects now predicted to enter our solar system on a regular basis. As newer generations of telescopes come online, the expectation is that astronomers may soon detect at least one interstellar object per month. These objects represent a unique opportunity to study material from beyond our solar system, fragments of other planetary systems, or perhaps remnants of phenomena not yet fully understood. Suppressing or prematurely dismissing anomalous data could hinder scientific progress at a moment when humanity stands on the brink of discovering unprecedented information about the galaxy around us. In addition to its mass anomaly, 3I/Atlas has been tentatively linked by some researchers to the famous 1977 WOW signal, an unexplained narrowband radio transmission detected by the Big Ear radio telescope. While no direct evidence proves a connection, Loeb believes the possibility should not be ignored. The WOW signal remains one of the most enigmatic detections in the history of radio astronomy. It has never been explained by interference, satellites, or known astrophysical sources. Some scientists argue that the only way to fully rule out or confirm any link would be through sustained observation, detailed spectral analysis, and transparent data sharing. The government shutdown and NASA's limited public disclosures cut directly against these principles. Even if the majority of astronomers believe the object is natural, the scientific method demands thorough investigation rather than rapid categorization. What many observers find troubling is not the idea that NASA might be concealing extraordinary secrets. Most researchers agree that such theories are unlikely, but rather that the agency sometimes prioritizes narrative control over scientific openness. Government agencies often feel pressure to maintain public confidence, avoid sparking speculation, and present events in the simplest possible terms. However, in doing so, they risk undermining the trust of the scientific community. When the available data contradicts early statements, the result is confusion or worse, diminished confidence in official assessments. Another important factor is the history of interstellar object research itself. The first two confirmed interstellar visitors, Oumuamua and 2I/Borisov, already demonstrated how rare and scientifically valuable such objects are. Oumuamua, in particular, sparked intense debate due to its unusual shape, acceleration patterns, and reflective properties. Loeb's hypothesis that it could represent extraterrestrial technology received widespread attention and criticism alike, but it also highlighted the gaps in our current ability to categorize unfamiliar objects. Lessons from these past events suggest that rushing to categorize 3I/Atlas without releasing supporting data risks repeating the same mistakes. Scientific inquiry thrives on collaboration, peer review, and openness. None of these can occur without access to the raw information. Moreover, the lack of deviation in trajectory despite massive mass loss has implications not only for the object's mass, but also its physical structure. A natural comet or asteroid shedding material at such a rate would typically reveal surface irregularities, spin changes, or spectral shifts. The absence of these effects raises questions about the object's composition, internal cohesion, and even its formation environment. Scientists outside NASA have noted that if the object truly is as massive as Loeb suggests, the mechanism behind its outgassing must be re-examined. For instance, could the evaporation be occurring from subsurface pockets? Could the object have an unusually high density or an internal composition unlike any known comet? These questions are not fringe speculation. They are legitimate scientific inquiries that require detailed data, not press summaries. The shutdown also delayed the processing of observational contributions from international partners. Space research is global, collaborative, and interconnected. When NASA stalls, it often affects the entire chain of scientific progress. Many space telescopes, including Hubble, rely on U.S. support infrastructure for data processing and analysis. Even if images were captured during the flyby, delays in processing would likely disrupt timely scientific evaluation. This makes NASA's rapid release of a narrative, without even preliminary graphics, more perplexing. The public deserves clarity on what happened behind the scenes between October 1st and October 4th. Why were some news outlets briefed, while the broader scientific community was left waiting? Why did NASA shift from saying analysis would take several days to providing early characterization less than 24 hours later? The lack of transparency inevitably fuels speculation, even among well-intentioned researchers who simply want access to the facts. Ultimately, no one claims that 3I/Atlas is artificial or connected to extraterrestrial intelligence. What Loeb and others argue is much simpler. The object exhibits anomalies that warrant ongoing study, and the public should be given full access to the data needed to understand those anomalies. In an era when interstellar objects are expected to become increasingly common, setting a standard of openness and scientific cooperation is more important than ever. The events surrounding the shutdown, the rushed narrative, and the unexplained physical characteristics of 3I/Atlas illustrate why vigilance and transparency remain essential. Science progresses not through silence or selective disclosure, but through open dialogue, rigorous analysis, and the willingness to follow the evidence wherever it leads.